Welcome to my channel. Please subscribe Basics of IoT Networking. The Internet of Things, IoT, is a network of interconnected physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity, enabling them to collect and exchange data. IoT networking involves connecting these devices and objects to a network to enable communication and data exchange. IoT networks can use various wireless and wired technologies, such as Wi-Fi, Bluetooth, Zigbee, and cellular networks. Wireless technologies are preferred for IoT networks as they offer flexibility and are easy to deploy, especially for devices that are difficult to access or move frequently. On the other hand, wired technologies are preferred for applications that require high bandwidth or security, such as industrial automation or healthcare. IoT networking also involves managing the flow of data between devices, gateways, and cloud platforms. This requires protocols and standards that enable interoperability and ensure security, privacy, and reliability. Common IoT protocols include MQTT, COAP, HTTP, and DDS, while security standards include TLS, DTLS, and IPsec. IoT networking also involves managing the architecture and topology of the network. The architecture of an IoT network defines the layers, components, and interfaces that enable communication and data exchange. Common IoT architectures include the layered architecture, where devices are connected to gateways or edge servers, which are then connected to cloud platforms, and the mesh architecture, where devices are interconnected directly or indirectly. The topology of an IoT network defines the physical or logical arrangement of devices, gateways, and servers. Common IoT topologies include star, tree, mesh, and hybrid topologies. Each topology has its advantages and disadvantages in terms of scalability, reliability, and cost. IoT networking also involves managing the power and bandwidth requirements of devices. IoT devices are often battery-powered and have limited processing and memory capabilities, which requires optimizing the data exchange and processing to minimize power consumption. Bandwidth requirements also need to be optimized, especially in applications that involve real-time data or video streaming, where network latency and bandwidth constraints can affect the performance and reliability of the network. Overall, IoT networking is a complex and evolving field that requires expertise in wireless and wired technologies, protocols and standards, network architecture and topology, and power and bandwidth management. As IoT adoption continues to grow, IoT networking is expected to become even more critical for enabling new applications and services in various domains, such as healthcare, transportation, agriculture, and smart cities. IoT components. IoT, Internet of Things, comprises a vast network of interconnected devices that are capable of exchanging data between them. These devices are usually embedded with various sensors and actuators that allow them to interact with their environment. The IoT ecosystem consists of various components, including sensors, actuators, gateways, cloud platforms, and end-user devices, which work together to facilitate the functioning of the network. Sensors are one of the essential components of IoT devices. They are responsible for detecting changes in the environment, such as temperature, humidity, light, motion, etc. The sensor data is then collected and transmitted to other devices, such as gateways or cloud platforms, for further processing. Sensors are available in a wide range of shapes and sizes, and they can be integrated into various devices, including wearables, smart home devices, and industrial equipment. Actuators are another critical component of IoT devices. They are responsible for converting electrical signals into mechanical movement or other physical changes. For example, A motorized valve actuator can be used to control the flow of fluids in industrial processes. Similarly, a solenoid actuator can be used to control the movement of a mechanical arm in a manufacturing plant. Actuators are typically used to execute a specific action based on the data received from the sensors. Gateways are devices that act as intermediaries between IoT devices and cloud platforms. They are responsible for collecting the data from the sensors and transmitting it to the cloud for further processing. Gateways can also be used to filter and analyze the data before transmitting it to the cloud platform. The gateway can be either a dedicated device or can be integrated into an IoT device, such as a smart home hub. Cloud platforms are essential for storing, processing, and analyzing the vast amounts of data generated by IoT devices. Cloud platforms provide a centralized location where data can be collected, analyzed, and acted upon in real time. Cloud platforms can also be used to provide various services, such as data analytics, machine learning, and artificial intelligence, to help businesses make informed decisions. End-user devices are the final component of the IoT ecosystem. They are responsible for providing a user interface that allows users to interact with the IoT network. End-user devices can include smartphones, tablets, laptops, and other devices that are capable of receiving and displaying data from the IoT network. End-user devices can also be used to control the IoT devices, such as turning on a smart home light using a mobile app.